Hi everyone, I'm here with your 811 lesson is the graph linear, patterns of growth in tables and graphs. Have you ever noticed that the sun rises earlier and sets later in the summer than it does in the winter? If you live north of the equator, you may have noticed that in December you often wake up for school while it is still dark. However, if you wake up at the same time of day in May, the sun is shining. The number of hours of sunlight in any one place changes during the year, unless you live directly at the equator. This is because the Earth's tilt changes in comparison to the sun. The number of hours of daylight is approximately equal to the number of hours of darkness at just two times of the year, the fall equinox and the spring equinox. If you compared the average number of hours of daylight to the time of year on a graph, you would be able to see a pattern in how the number of hours of daylight changes. Today, you will explore situations, tables, and graphs that change in different ways and build strategies for visualizing different patterns of growth. As you work today with your team, ask each other these questions. How does this grow? What happens when one measurement changes? And how can we see the pattern of growth in the table? So let's flip over to 8.2. 8.2 says, now that you have predicted what different graphs will look like, which we did skip that problem, that's okay. You will investigate how some of the measures are related. To start, consider this situation. Oscar puts $1,000 of principal in a bank account that earns 2% simple interest each month. He wants to track how his money is growing over time. Oscar is using the formula at right to calculate how much interest he will earn on investments that are earning simple interest. He knows that, simple interest is paid only on the original amount that was deposited, the principal. For an amount of money that was invested for 2 months, he wrote the equation below. I equals 1,000 times 0 and 200ths times 2 equals $40. A. On the lesson 811A resource page, complete the table to show the interest Oscar had earned after 1, 2, 3, 4, and 5 months. How do you find this new balance? How do you find his new balance each month? So I'm going to have you flip to the resource page. And they already did 0 months for you. Okay. Obviously, because it's 0 months, 0 interest, you put $1,000 in the bank. I would like you to finish filling out this table. Make sure that you are using your formula I equals PRT. So go ahead and work on that for a minute. Okay, if you're back with me, you filled in your table. So at 1 month, he earned $20 interest. So this would be 1,020. 2 months was $40 interest. 1,040. 60. 80. 100. And then 6 would have been 1,120. So to do this, I equals your principal times the interest rate times the month. I equals the, principal times the interest rate times the month. Principal times the interest rate times the month. Okay, see the pattern that I'm doing here? It's always the principal times the interest rate times the month. You could just put this into your calculator. Okay. B says, make a graph comparing months of interest on the resource page. So if you go back to your resource page where we just were, there's a graph at the bottom. Go ahead and graph those points that you just came up with from the table. If you're back with me, you've made your graph. Let's take a look at mine. Okay, so again, we just got those points from the table. At 1 month, he earned $20 interest. At 2 months, $40, etc. So we know that we are going up 20 and over 1. That is what our slope triangle is. Okay. Looking at C, what patterns do you notice in the table and the graph? How can you see each pattern in other representations, situation, table, and graph? So let's talk about this. So I just said this kind of with the slope triangle. We see that the account balance increases by $20 each month. So in the situation, 20% of 1,000 is $20. The table you can see how the bank balance changes. For each month. And in the graph, it's your slope triangles. D says, use the patterns you have found to predict how long it will take before Oscar has $1,800 in the bank. Justify your prediction. So go ahead and make your prediction. Okay, if you're back with me, you made your prediction. A couple ways you could have done this, but I'm going to show you what the correct answer is. So we know that we go up $20 each month. So if we did $1,800, because that's what we want, minus the $1,000 principal, we would get $800. Whoops, you can't even see that, sorry. $800. If we divide that by 20, because we know we're getting $20 each month, that's going to give us 40. So at 40 months is when he would have $1,800 in the bank. Okay, we're going to skip over part E, I'm sorry. Let's move on to problem 8.3. Profit, profit, profit. Anita bought a special baseball card for $8. Later, she decided to sell it, but she wanted to make profit. She added 50% to the price she paid and sold the card to Brandon. When he decided to sell it, he also wanted to make a profit, so he added 50% of the price he paid for the card and sold it to Casey. Casey increased the price by 50% and sold the card to Eli, who increased the price another 50% when he sold it to Fernanda. On the 811B resource page, make a table and a graph of the new price after 1, 2, 3, 4, and 5 exchanges. How do you find the new price at each exchange? So go ahead and flip to your resource page. So we have to ask yourself, we know that each time it's increasing by 50%. So 50% of the new price here is $4. So after one price exchange, our 50% of 8 is 4. So the total price is 12. Now we need to do 50% of 12, which is $6, and add it to the total price. 50% of 18 is $9, and add it to the total price. 50% of 27 is $13.50, and 50% of $40.50 is $20.25. So your total price would be $60.75. So again, you just ask yourself, okay, the new price, 50% of that is going to be the price increase, and then add those two prices together to get your new price. B says, what patterns do you notice in the table? What patterns do you notice in the table and the graph? Is the graph a straight line? How can you justify your conclusion based on the table or graph? So go ahead and now graph these points that we just came up with in the table on your resource page. Do that first. If you're back with me, you've graphed. This is what your graph should look like for this one. Oops. Okay. So this question that we're on right now is asking us about the patterns. So something that you should have noticed, hopefully, is that the price increases by more and more with each change of the owner. Therefore, the graph is not growing at a steady rate. That's why it's curved. Okay. So D, how much did Fernanda pay for the baseball card? Well, Fernanda, you have to go back and look. That's the original. So you have to ask yourself, okay, this is the original. This is exchange 1, exchange 2, exchange 3 was to Eli. Eli sold it to Fernanda, so that's exchange 4. So if you go back to your table, the fourth exchange, she paid $40.50 for the card. Eight 4. In problems 8.2 and 8.3, one graph made a straight line while the other curved. How was the situation that created a straight line changing, growing? So go ahead and try and answer that. So hopefully for A, you saw that the change was a constant. $20 each time X increased by 1 month. B says, growth that creates a straight line shows constant change and is called linear growth. What made the graph in problem 8.3 curve? How did the growth show in the table and in the graph? So we know this one's constant. We know that B was not constant, or problem 8.3 was not constant. The price increased each time the card was exchanged. You're on the graph. As always, growth can be seen with your triangles. And in the table, growth can be seen by the difference in y values. Okay, that's it for this lesson. If you have any questions, please make sure you email us.